Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss one question that was asked in May-June 2015 paper. In this question, they had given one star circuit and the question was convert the given star circuit into its equivalent delta circuit. This was a simple question asked for 3 marks, but it was asked as a compulsory question. So this was based on the star delta transformation that we have discussed in one of the topics in the very first chapter. Here we have to convert the given star circuit to the delta circuit, so we'll be using appropriate formula of star to delta conversion. So if you remember, as per the notations that we have used, the resistors in star network, we had called them R1, R2 and R3. So let's say this is my resistance R1, this is my resistance R2 and this is my resistance R3. So as per R1, R2 and R3, we will now define the corresponding resistors in the delta network, and the notation we had used were RA, RB and RC. So RA, that is the resistance in my delta network, is going to be equal to R1 plus R2 plus R1 R2 upon R3. So that will be the formula for RA. Similarly, RB is going to be equal to R2 plus R3 plus R2 R3 divided by R1, and RC is going to be equal to R1 plus R3 plus R1 R3 upon R2. So if you observe carefully, when I take R1 and R2 here added together, we have to consider the product of R1 R2 and divide by the third resistance, which is R3. If I'm adding R2 R3 first, then consider their product and divide by R1 this time, and if we add R1 R3 here, consider their product and we will be dividing by R2. Now the question is why we have taken R1 R2 for RA, R2 R3 for RB and so on. That is simply because when I connect a resistor between nodes A and C, so between node A and C, because they also form the ends of resistors R1 and R2, I will be connecting RA between A and B, and that's how formula for RA has R1 R2 added and then multiplied and divided by the opposite resistance, which is R3. Similarly, when I connect a resistance between B and C form the ends of R3 and R2, which we are using here in the second formula for RB. So RB will be connected here, and likewise if I define the resistance between A and B, it is going to be nothing but RC, because A and B form the ends for R1 and R3, and these are the resistors we have used for RC. So let us find out all the three values and draw the equivalent delta network. So as you can see, R1 and R2, the values given are 2 and 6. So this will be 2 plus 6 plus 2 into 6, that's 12, divided by the third resistance is equal to 4. So this will come out to be 11 ohms. The next resistance RB, which is connected between B and C, will be R2 and R3 are given as 6 and 4. So 6 plus 4 plus their product, which is 24, divided by 2. So that is going to be, this is 10 and plus 12 will be 22 ohms. And the last value, which is for RC, is going to be equal to R1 and R3, which is 2 plus 4, that's 6. And product is 8 divided by the third resistance, that is 6 in this case. And this is going to be equal to 6 plus, this is 1.33, so that will be 7.33 ohms. So finally, we draw the delta network as per the question asked. And in this delta network, this will be my original point A, this will be point B, and this will be point C, and the values will be RA equal to 11 ohms. This was my resistance RB, that is equal to 22 ohms, and this is resistance RC, that is equal to 7.33 ohms.